3, 2, and 1, and we are live with Little Shop of Physics Live. So welcome to the LSOP Live Studio, and we have a special show for you today about light and color. And for PSD teachers who are participating, we've sent you out pairs of glasses for your students to use. And the first set we're going to use is these rainbow glasses right here. And we have a few different kinds, but they're ones, when you look through them, you see, yeah, rainbows. That's a pretty clear tell. These are the rainbow glasses. They break light up into a spectrum. We have a series of demonstrations that shows how they work. For these, you want the glasses off, because we're going to put our own little rainbow glasses in front of the camera. Over to Emma, who is going to tell us some things about light and color.
Yeah, so as fun as these glasses are, we're just going to ask you to take them off really quickly because we have a special lens that we are putting in front of the camera. Actually, we're just putting the rainbow glasses in front of the camera. So that should make it easier on us. And the first thing we're going to do is look at white light. And what you'll learn from your rainbow glasses is when you put them on and you look at a white light, you see the whole rainbow. You see red, orange, yellow, green, blue, and purple. And the reason for that is because white light is made up of all the different colors. And when you look through your glasses, it splits it up into all those different colors. So if we could turn the lights off.
Oh, yeah. Thank you, Emma, for reminding me. I was supposed to do that, and I was just so transfixed by what you were saying.
Turn this white light on and put the glasses in front of the camera. You can see the whole spectrum of light.
Look at that. I got a rainbow to the left and a rainbow to the right. That is awesome. Mm-hmm. That is awesome.
Which is pretty similar to what you can see if you just look at the lights in your classroom. But what's super cool is what happens if I put a color filter over top of the white light.
Oh, and what color is this filter?
So this filter that I'm about to put on is yellow. And you'll notice when I do that,
it kills the blue.
So why is the blue missing is the question here. And what we've discovered is that the colors that you do see are what's being reflected. So that's what's hitting your eye. But what's missing is what the light is absorbing. So
the white light, which is all the colors, goes through there, and the red and the green make it right on through, but the blue gets shut down. The blue gets absorbed.
Yeah. Cool stuff happens too if I put this red filter over top of it.
Oh, wow. That looks like it ate the blue and the green.
Mm-hmm. Which means it's absorbing the blue and the green.
Awesome.
And then lastly, I have a green filter here that's pretty cool.
Whoa. And that eats everything except the green. Maybe a little bit of red?
Maybe.
You all see a little bit of red there?
Definitely.
A little bit of red comes through? That is awesome. That is awesome.
All right. And then another thing that we can do with spectra is look at the absorption spectra of different gases. So I have a really cool experiment here that is these light bulbs contain different gases. You might not be able to see it with the light right now. But I'm going to plug them into this thing in just a second, and it'll show off a light, and then we can look at the spectra of that light. Let me turn that off.
All right. And it's dark. Oh, that's pretty.
That is the mercury.
Oh, my gosh. And Ty, what colors do you see in there?
I see green. Definitely the blue.
Definitely some green and some blue.
Mm-hmm.
And that's why we're getting kind of a little blue-green thing going on there. That is awesome.
Right,
That is awesome.
And then I have all the other elements with me, too. See which one I grab next.
Ooh.
Wow. That's pretty.
That's real pretty.
Yes.
And it's a little out of focus. Let's see if we can sharpen that up a little bit.
The neon, I think.
This is neon. Oh, yeah, that's much better. That's much better. Oh.
Wow.
Oh, nice. Nice, nice, nice. And so when we break that up, Ty, what are you seeing there?
I see yellow, orange, and red.
Awesome. So it's all those red colors, which gives you that awesome red look. Mm-hmm. And actually, when people see neon lights around town, one of the things that's commonly in them is, of course, neon, but also mercury. That's how you get the reds. That's how you get the blues.
Awesome. All right. And then we have one more, which is argon.
Ooh. Oh, that's pretty.
This one's a little bit more dim, a little hard to see, but, oh, we got it.
Oh, no, there it is.
Wow.
Oh, my gosh. And look at the lines. You can clearly see. Ty, what do you got on that one?
Definitely some blue. I think that's green.
Yeah, I think a blue and a green.
Yeah,
And
and
a
maybe
orange?
a little red or orange.
Red
yeah.
or an orange.
I like that.
That is awesome. And that spectrum's characteristic of the gas, right?
Yeah, we even call it the gas's fingerprint because each gas has a very specific spectrum. And that's how we know what stars are made out of.
What? We look at this.
Wow.
So astronomers just take a pair of rainbow glasses and stick them in front of the telescope, is what you're saying?
Pretty much.
That is actually pretty much what
Pretty
they do.
much.
Pretty much what they do. They break that light into a spectrum. And I like the idea of it being a fingerprint. That is
Because it's
awesome.
unique to which gas.
That is awesome.
Yeah.
That is awesome. So what else could... And then kids have your own rainbow glasses, right? And what kind of things, if you were a kid and you put on your rainbow glasses, what kind of things could folks look at? Rebecca, what do you think? What would you be looking at?
Well, I personally see a lot of Bryans. A lot of Rainbow Bryans.
Rainbow Bryans, which is awesome. But I would look at all kinds of light sources and
Exit
see what
signs.
you see. What's that?
Exit signs.
Exit signs are good. Exit signs are good. But there's one thing you should never look at with your rainbow glasses.
The
sun.
The
sun.
sun, yeah. So don't be looking at the sun, you little rascals.
I
So
will not be happy.
don't do that. No. Now, there's more to light than just the rainbow, though. We've seen all the visible light colors, but Rebecca's got a little demonstration that takes us beyond the rainbow. Ooh.
I do. I have some really cool stuff over here. I have this little light and this fun little solar bug, which has a lot of different parts to it that make it work and make it move, but the most important one is this little solar panel right here. And when I put it over just the regular light, it works and it does a little dance. You can kind of hear it. I'm real quiet.
Oh, yeah. Now you can hear it.
Yeah.
It's buzzing.
It's
so
buzzing.
It's dancing around because it's got light shining on its
Yes.
belly.
This light right here goes into the solar panel and it makes it move. But then I have this piece of plastic. And this might just look like a regular piece of black plastic, but it's not. It is actually infrared plastic and it blocks every type of light except for infrared. So I'm going to put it over and that makes the light kind of go away from what we can see. And I'm going to put back the bug on top of it and see what happens.
It's still dancing,
It's still...
even though we don't see any light.
Yeah,
crazy.
it was kind of crazy when I first tried this one. But yeah, it's because the solar panel works with infrared light because that is a huge part of what's in the sun.
Oh my gosh. And so the solar panel is picking up the visible light, but it's also doing the infrared. And so this is just giving it basically a little bit more energy. And the solar cell is taking energy from the light and it's turning it into the energy of motion.
Yes.
And so light is carrying energy. And Ty, you got some solar cells going on over here.
I do. So here I have flowers, and if you can see, in the front they also have solar panels. So it's going to absorb the light, and then they're going to dance. We don't have sun.
Yeah, then why isn't it working? They're not dancing already.
These lights, what's wrong with these lights?
These lights I don't think they're very bright. It's kind of dim in here. And there's
Right.
also no infrared out of here. And we know that this solar cells, they like themselves some infrared.
And then, so since we don't have sun in our room right now, I have a light.
Oh
a
my gosh,
lamp.
there it is.
And so I'm going to press it. And now,
Oh, look at those little dancing flowers.
yes.
they're
And now they're dancing.
very happy. Eating up that solar energy and saying, yum, 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 give me more of that. That is awesome. That is
Thanks.
awesome. Now, I got here a really, really bright camera flash. And so this light carries energy, and this will give you a huge pulse of energy very, very quickly. And a lot of energy in a very short period of time. And I have a pen here, and I love to use these for science demonstrations. And this one is a pen that you can erase, and you erase it with heat. And so I'm going to go ahead and write on my piece of paper here. I'm going to write Little Shop of Physics because that's kind of a classic here. So if I write Little Shop of Physics, I'm writing in this pen. And if I want to erase the writing that I've put down, all I have to do is get that pen really warm. And one way I can get it warm is I could use friction, so I could use the little eraser on the pen. But instead what I'm going to do is this. I'm going to go ahead and hit the writing on the paper. And let's see if we can see the writing. We're going to get a little bit more contrast. There it is. There's the writing on the paper. And then I'm going to hit it with light from the camera flash. And then that black writing is going to absorb the light.
Wow.
Whoa. And it's gone. It is gone.
Goodness.
Fortunately, the little shop of physics isn't, but the writing is gone. The writing is gone. So we were able to make it go away because we added a lot of heat to it in a hurry. And as a matter of fact, this camera flash is so good about depositing a lot of energy very quickly. We can actually like vaporize things. Here's a copy of our school newspaper, the Rocky Mountain Collegian, and I got a little black spot down here, so a lot of black ink. And if I take this camera flash and I bring it down near the black ink and I put it on the paper and flash it, you can see a little smoke rising from there. I'm going to hit it one more time here. Let's let it get up to full charging.
Let's do this bit here.
All right, we're going to do this bit right next door. Full charge, here we go, and we hit it. We get a little bit of smoke rising from that, which is kind of awesome, kind of awesome. And the other thing we've been playing with, if you have these receipts, we have that come from stores, a lot of times they'll have, they're thermal paper, so they get dark when they get warm, and that's the way we print, is not with ink, but just by getting them warm or getting them cool. So this particular scrap of receipt has some writing on the back, and I promise we're not doing anything. You know, we're not getting any money from REI, although Emma says she gives a lot of money to REI.
I do.
So I take this receipt and I put it upside down, and if I hit it with a camera flash, what it'll do is the light goes through the receipt and kind of like picks up the dark from the other side. And let me do that one more time here. We're starting to get some of that writing from the other side is kind of coming through. And we like this most with the little target receipt. So I got the little bullseye here. And if I hit this with my camera flash, I get it to full brightness. We start to bring that little bullseye through from the other side and make it nice and dark. There we go. And I could, oh my gosh, and look, the writing from the back side came through. Look at that. That is awesome, because that was writing on the back of the receipt, and I brought it through to the front with the light. Now, next thing we're going to do, so light carries energy, and Ty has got a rather dramatic demonstration of that principle.
So here I have a red balloon, and I have a green laser. So red absorbs green light.
So the red balloon is going to absorb the green light. Oh yeah,
Yes.
because it's all the light colors of light are coming in. It's reflecting the red, but just like the cup fillers that Emma had, it's absorbing the other colors.
Yeah. So I'm gonna hold the laser onto the balloon for a little bit.
Oh, that is a bright laser.
It is very bright.
You might bring it closer and get
I
it
can
just
do it closer.
steadily in one spot. That is definitely bright.
And it should work.
Oh! Whoa!
And then it pops. And you see the little hole where the laser
It
burns.
made a little hole where the laser burned a hole in it, which is kind of awesome.
Yeah.
That's not just a single balloon. That's a double balloon,
It
right?
is. There was a purple balloon in here as well.
Oh my gosh!
And that definitely popped.
And you popped the balloon inside the balloon, so
I
that's kind of
did.
cool. Now you got another balloon, right?
I do, so we can show it again.
Awesome. And this is a red balloon with a yellow balloon
This one
inside it,
is
right?
yellow.
Let me hold this so
Oh,
it's nice and
please.
steady
Thank
for you. Okay, so we have a red balloon
Okay.
with a yellow balloon inside. Oh! Whoa.
That one was faster.
I knew what was going to happen, and I still jumped.
And then we popped the red,
Yes, but not the yellow.
but not the yellow, because the yellow, of course, yellow is going to be reflecting red and green, so it's not going to absorb that. If you put the green laser on the yellow balloon, it won't pop.
No, it won't.
It just shines
It
nice
looks
and
a
green.
really nice
it looks
color, though.
gorgeous.
Yeah.
It looks gorgeous, but it reflects the green, doesn't absorb it. Whereas you put it on the red, it's pretty poppy.
Yeah.
That is awesome. That is awesome. Next thing that Ty is going to show us, there's a difference. There's something interesting that's different with different kinds of
Okay, here I have a glow-in-the-dark
Lights.
basketball. If any of y'all like basketball,
heck yeah.
this is the coolest ball to have.
You can continue playing after dark.
Yeah, you can. And then I have 3 different lasers. One is blue, one is red, and then one is green. So I'm going to shine the red laser on the basketball. And
Boring.
it is very boring.
I thought you said it glowed in the dark. Nothing's happening.
Well, maybe we'll try the green laser.
So the green laser. What
Okay.
happens with the green laser?
Still nothing.
Boring.
I'm sorry.
Boring.
Well, let's see the blue
The
laser.
blue laser.
What?
Oh, now that's better. That's better.
And see, I can write with the laser.
On the balloon. That is awesome. And what's different with those different colors? And I think those different colors are just got different. So let me ask you a question. Like, which kind of light has more energy, the red or the green or the blue? Oh, Emma is raising a hand. You have to raise your hand in here, you
I
rascal.
think the blue has the most energy.
Blue has the most energy.
Really?
And we said it's made of photons, and the blue photon is just more energetic than the red or the green. But light's got all these different kinds of photons in it, and some of them have more energy than others. And we got a question for folks right now. Emma, why don't you pose a question
Yeah.
to these folks?
So here in front of me, I have a really cool solution that I made. We call it a chlorophyll extraction, which is just a super fancy way to say I took the pigment out of the plants. So this is green because it's made out of plants. And I have 3 different colors of light. A green light, a blue light, and a red light. And we wanted to ask you all, what color of light do you think the plant would absorb the most of?
Awesome. And we're going to put a poll up. And is the poll already live? So we're going to say, what color of light did the plants absorb? And so go ahead and weigh in. You should be seeing a poll. Actually, I'm going to relaunch the poll. Here we go. Here we go. Now it's working. There we go. Now I got the poll. Sorry, that was my technical problem on my end. So talk it over with your class. What colors of light do plants absorb? And you can put more than one answer in. Oh my goodness.
Interesting.
We have a definitive trend that's taken shape here.
Definitely.
Folks are saying plants absorb red and they absorb blue is what folks are saying.
Interesting.
That's what they're saying. And I was kind of like thinking plants are green. Maybe they like themselves some green light. But the folks are saying red and blue. I think we got to do a test here.
We do. We have to
Let's
do a
do
test.
this.
All right. So everyone's saying red and blue are absorbed the best. So let's start with the red. You can see I'll shine it in.
Ooh.
And the red is kind of getting eaten up, isn't it? Because that's a
is.
really bright flashlight.
It's a pretty bright flashlight, and when I shine it in the solution, it doesn't quite look as bright. And from the angle I'm seeing it at, the red light beam doesn't even make it all
And
the way
try
through.
from the top.
Try it from the top.
Yeah, if you light that up, yeah, you can see the red it's not really, it's kind of getting eaten up. I'm not seeing a lot of red light inside. There's a really bright flashlight, but I'm not seeing it.
See the
And
blue?
if you try blue, blue actually makes a red spot, which
Yeah.
is kind of awesome. Get a little bit of fluorescence going on there.
And
But it's
then-
not, it's getting completely eaten. Look,
Yeah.
red is gone.
And then if we try the green, wow.
Whoa, whoa. And the green is kind of like scattering and going all over the place. That's really lighting up the beaker.
Totally reflected.
Oh my gosh, oh my gosh. So it's absorbing the red and the blue. Folks were correct.
Wow.
Oh my gosh.
awesome.
We can't sneak
Impressive.
anything past these
No.
kids.
We really thought we were being tricky there.
Those rascals. Now we've got, let's see, next up, Emma's going to show us, and we have two different kinds of filters and two different kinds of pictures, right?
Yes, I have some secret messages here
Ooh.
that can only be decoded using some physics of light. So here, if Patrick could get in close to my messages, they're kind of a little bit confusing at the moment.
Yeah, that looks like.
Like, who is that? I don't know.
That looks like a bunch of scribbles.
And we got to figure out what this message says, too. So I'm going to start with the writing.
Okay.
And if I put a red filter over top of it,
Ooh.
now you can see it.
LSOP is the best.
It is the best. Same with the little picture I've drawn. If I put the red filter over it, it's Brian.
Wow.
But what's drawn in the red then?
Oh my gosh.
Please tell us.
Because we gotta find out. If I put the blue over top, there we go.
Oh, and it says.
I love physics.
I love physics. I love physics.
And then who's underneath here?
Ooh, that's Isaac Newton.
that is
I recognize
Sir
that. So I have two pictures on top of each other, and using one filter I see one, and using the other filter I see the other.
Absolutely.
But wait a minute. Kids have special glasses that have just such filters in them.
Mm-hmm. You get your red and cyan 3D glasses out right now. We've got some pictures to show you that hopefully will...
Oh, yeah, and
perfect.
these, here they are. Oh my gosh, that picture looks decidedly three-dimensional. So I have two different pictures going to my two different eyes, and that allows me to see a 3D view.
Yeah,
Emma, where did these come from?
these came from the Mars rover. The Mars rover has two different cameras on it, and it has the ability to take two different pictures that are different distances away. And so when we put them on top of each other and put one in red and one in cyan, and we put our glasses on, it looks 3D.
Oh my gosh, that is amazing. And you want to be having the viewer on with the writing out. Because I put my viewer on backwards, and it was like, that was sad. That
We've
was
got some more pictures.
We need another one.
Yeah, we need another one for sure.
Oh my gosh, that is solid.
Crazy.
These were really taken from Mars, too.
Oh my gosh, and if I move my head
so
back and forth,
cool.
it looks like the image shifts.
Whoa.
Oh,
It
that's
does.
good. That is awesome. That is awesome.
See another one?
Oh, we need to see another one. Yes.
Oh, the craters.
Whoa.
Whoa.
Awesome.
Feel like I
Let's-
could stick my hand in it.
Oh my gosh, that is awesome.
I think there's two more.
Let's do them.
More
Oh, that is awesome.
Crazy.
I tried to pick out just the coolest ones I could find, but
Oh, these
there
are the
are
best.
so many of these on the NASA website if you wanted to go look for yourself. There's one more photo. Cool.
Oh, let's see it. Oh, yes.
This one's
Oh
my
my
favorite.
gosh. And so you just did an image search for like Mars 3D photos,
I
right?
did, and they were right off the NASA
Oh my
website. They even
gosh.
have videos on NASA.
Really?
too.
You can have 3D videos?
Mm-hmm.
I'm watching 3D Mars movies tonight. This is the best. But wait, there's more. We have another way to do 3D.
Oh.
Ty, what's our next way of doing 3D?
Our next way of doing 3D is chroma depth.
Chroma depth. Oh, yeah.
Yes.
And so these things are kind of a relative of the rainbow glasses.
Yes, they are. And so earlier we showed our representation of Brian and then a cat, a kitty.
So let's take a look at that. And everybody we need everybody to get these glasses out. This one, you need to be wearing these to be able to see it. So everybody get your Chroma Depth glasses out, and the ones that are a little beigey, they got the full color Little Shop of Physics logo on them. Put on your Chroma Depth glasses, look at your screen, and oh my gosh.
And this print is super cool because it looks like my hand should go under the red,
Oh my gosh.
and it doesn't,
This is decidedly 3D. It looks like the screen is actually pushed in.
right?
Like it looks like the screen I'm looking at has some depth to it.
And
Oh, and the little kitty's floating.
but
It's a little floating
it's
space
not.
kitty.
And then we can have a floaty Brian.
Awesome.
Brian's dancing.
That is awesome. And now I'm going to do next, I want to go over to Rebecca because there's something else we can do with this cyan filter, right?
Yes. I'm actually, this time you don't need your glasses. I'm going to have Patrick put a filter over the camera.
And that he's going to put, the filter he's putting over the camera is the same cyan filter that's in the glasses,
Yes,
right?
it's the
So if
exact
kids want to
same
try
one.
this later,
Yes.
you can do it yourself just by looking through the cyan side of your glasses like Emma is demonstrating right there. Oh my gosh, and everything looks real different.
Okay.
No.
I'm gonna wait
So
until
Patrick-
the filter's over the camera so I can bring this out. Okay.
Oh,
I
and the
have
filter's not there yet?
This... Oh, it's not there yet.
Not there yet?
Oh, just kidding.
There
There it
it is.
is.
There it is.
There it is.
Okay. Perfect. Here is a little grass with some tigers, and I want you guys to answer in the poll how many tigers you see.
So there's little tiger figures in there?
Yes.
I don't see them,
That's
Rebecca.
insane.
See
I
I
them
don't
at
see any
all?
tigers.
Not at all.
I don't see any tigers. No, seriously, I do not see a tiger.
The fun thing about that is most prey animals of tigers, they can't see the color red.
Oh, and kids
So
are
that's-
saying 3 and 7 is what kids are
Oh,
saying. Oh my gosh.
interesting.
Let's give them another minute to keep
Yeah.
voting. How many tigers are in there? I am not seeing tigers. 3 is out in front. Oh, and somebody says 1. Somebody's got 1. We got 1, we got 3, and we got 7. That's what people are answering.
Oh, crazy.
Oh my gosh. Well, I think we need to cut to the chase and see just how many tigers are there.
Yeah. Patrick, if you want to remove the filter, there's actually 1 right here, 2, and then 3, 4, and the last one is,
No, skip it.
oh, I took some of the grass with me, 5. And
5 tigers?
5 tigers?
5 tigers.
Now, why weren't we able to see the tigers?
Well, because most prey animals, they don't have red cones in their eyeballs, which makes them unable to see the color red.
Oh, so the cyan filter basically cuts out the red.
Yes,
so
it
that was
cuts out
making us see like a deer, is what you're saying?
Yes.
That's awesome.
So that's what they would see. So oranges and greens look exactly alike to a deer.
Oh
or
my gosh.
A few other prey
So
animals.
tigers can hide in the grass like we can see them,
Yes.
but the deer can't.
Yes.
Oh my gosh. I
This
did
one's
not.
scary.
I did not. That is.
It's scary.
And Rebecca, I think we're going to let you just kind of keep going. You're on a roll
Oh,
here if we can do
yes.
this. Because your next thing is using a fish tank here. And this is our next property of light we're going to do.
Yes.
We're going to look at
So-
reflection and refraction.
I have this cool little fish tank here, and I have a fun little fish that you can see above the water. Oh, let me turn it for you so you can be
Awesome.
seen a little bit better. Perfect. So
But
above
let's
the
let Patrick get in place here. So Patrick's going to bring the camera in, and we're seeing a fish above the water. So there's like one fish.
one fish. Oh, it jumped over here. What
And now it's,
happened?
wait, hang on. And move it a little closer to the corner of the tank. Yeah, there we go.
Oh,
One fish, 2 fish.
Wow.
One fish,
Whoa.
2 fish. One fish, 2 fish.
the water.
Oh my gosh. But how about if you do it on the other side?
Oh. You can't see it? No fish?
No fish,
One fish.
1 fish. 1 fish,
No
fish.
fish.
Oh,
Oh, and I like 1 fish, 2 fish better. That seems happier.
know.
And the other thing is your hand looks like it jumps.
yes. Wait.
And you just took a fish tank filled with water, right?
Yes.
And you're just moving above the water and below the water.
yeah,
This
just
is
up and down.
this is not, and you're making 1 fish turn into 2.
Yes.
And then if you put it on the other side, you're making 1 fish turn into
into none.
no fish. Crazy.
I know.
And that's properties of refraction and reflection, which you've been learning about in physics with me, which
yes,
is kind of
I
awesome.
Have.
But wait, there's another thing with light you're going to do, right?
Yes. I have. Perfect. I'm going to need your help, Emma.
I got this.
Awesome.
So, what I have here in this little container is I have some highlighter juice that I just got from some highlighters. Perfect. And I'm going to take off the tape, and if you want to pop your finger over the hole. Perfect. I'm going to pop off this lid. And I'm going to put a couple of drops of highlighter stuff in there.
And the cool thing about the highlighter juice is it's fluorescent.
Yes.
So it absorbs, when it hit, certain colors of light hit it. Oh my gosh, look at that little plume of highlighter juice going down.
That's awesome.
And then when it hits the laser, what?
Trying to get it in
Wow.
the right
It makes
spot.
that laser way bright. And that laser light is like following the stream of water.
Yes.
Oh, and it hitting
awesome.
your finger.
If it's hitting my finger, the light turns blue.
Oh my gosh, that is awesome. So the light is actually following the stream. And actually, that's how the light that is transmitting the signal that we are broadcasting on gets to the people through like a fiber optic.
Yes.
Oh my gosh. And we are at 11:30. I'm sorry, we're at 12 o'clock. And it is time for us to say goodbye because I know the kids that we're working with, they have other things that they need to learn today. We could do physics all day.
Yes.
They can't. But we want to thank you for joining us. Definitely drop us a note anytime and tell us what you think about the program and what you'd like us to do next. We're going to be back Friday before spring break, and our next show is going to be magnetism. Let's do it. Let's do it. All right. We'll see you folks on the next one.